According to Ecotricity, the world's first green electricity company based in Britain, we will run out of oil reserves by 2052, shown by the blue marking on the graph. And if we fill the gapping need of oil with gas, then we will run out of gas reserves by 2060, shown by the red markings. And if we increase coal production to fill the energy gap left by oil and gas, we will run out of coal reserves by 2088. As you see in the figure, the availability of fossil fuels is quickly vanishing as we rely heavily on fossil fuels for energy. There is continual research going on in order to find sustainable alternative energy sources. The sun is a very powerful source. If we can find a way to harness a slight percentage of this energy, then we could begin to replace fossil fuels with a clean, renewable energy source. Solar energy is a strong alternative energy source because of the unharnessed energy still left to be harvested from the sun. At the end of this presentation, you will know the availability of fossil fuels left, some of the current alternative energy sources, and how and why solar energy is the key to the future. First, we will see our reliability of fossil fuels and electric energy consumption. We rely on fossil fuels for 66.9% of our electrical energy in the United States, while only 33.1% comes from outside sources such as renewable energy sources. That means if all of the world's non-renewable energy reserves ran out today, over 2/3 of the United States would be without electricity. As I mentioned previously in the presentation, fossil fuels are quickly depleting. As Ecotricity predicts, oil will run out by 2052. Can you imagine the gas prices? You would be forced to walk or bike if you wanted to afford even a small one-bedroom apartment. Well, what about gas? Do we have enough gas to completely fill the gap left behind from oil? If we increase gas production to fill the void of the oil, it would only give us an additional 8 years to 2060. So according to these predictions about the amount of fossil fuels we have left, is it really the end of fossil fuels? Technically, no. It will not be the very end of fossil fuels. According to an article published by Rice University, fossil fuels come from remains of plants and animals from millions of years ago. As these plants and animals decompose in the earth, they are compacted and created into fossil fuels such as oil and gas. But based on the current fossil fuel reserves, we have until the year 2088 until we run out. There are, however, new reserves of fossil fuels being found, but they are becoming more difficult to find and smaller in size. With the low supply of fossil fuel and the growing need for energy, researchers and scientists are turning toward different alternative energy sources. About 9.9% of the United States energy is derived from renewable resources, while 90.1% come from outside sources such as fossil fuels. And of that 9.9%, about 25% of the renewable energy sources in the United States is from hydropower, or power generated by water. Next most is biomass biofuels at 22%, biomass wood at 21%, wind at 19%, biomass waste at 5%, solar at 5%, and geothermal at 2%. The reason solar is only at 5% is because today's methods of producing solar energy are very inefficient. The current energy sources are not suitable to be sustainable for an entire country, never mind the whole world. Solar energy could be the key if researched further to help solve this problem. In a research project done by Santiago Moret in June of 2014, a PhD student from the University of California at Berkeley, he explains that the sun is, quote, virtually infinite reservoir of renewable energy. In this figure, Moret shows just how much energy the sun puts off every year compared to the other forms of energy. Moret also states that, quote, it has been estimated that if only 2% of the solar energy hitting the Earth every day was captured, all of humanity's current energy needs would be met and even exceeded. End quote. This statement was made in 2014, but this statement just shows how powerful the sun can be. In a study done and published by MIT in 2015, solar power only accounts for about 1% of the global electricity generation. So what are some ways that we can harness the sun's power? There are two, quote, solar to electricity technologies, end quote. And the first one is through photovoltaic cells, and the second one is concentrated solar power. Photovoltaics is the primary technology, accounting for about 98% of the total solar energy generated. The difference between the two technologies is that photovoltaics convert the sunlight directly into electricity, while concentrated solar power converts the sunlight into heat first and then into electricity. According to Moret's study, there are a few different ways to collect solar energy, depending on whether you're using the photovoltaics method or the concentrated solar power method. For the concentrated solar power method, the sunlight is directed by using mirrors on a single point. Then the heat from the sunlight is used to boil water, and then from that water generate high energy steam. Then the steam is converted into electricity. For photovoltaics, solar panels are used. There are also two other methods to creating solar energy. That's through biofuels and artificial photosynthesis, but these ways aren't nearly as common and aren't as researched as the previous two methods. So how do solar panels work? SolarGain, an accredited solar energy company, explains that it involves the use of a fluid passing through a heat sink exposed to sunlight. Since this is a photovoltaic technique, the panels do not rely solely on heat, just on sun rays. The panels convert sunlight directly into DC electricity. How does this happen? The photons from the sunlight strike the silicon cell within the solar panel, and then electrons are released. The newly freed electrons race around really fast around the panel and with the help of an electric field create energy. Next, the DC power travels through all the panels until it reaches the solar inverter. At this point, the DC electricity becomes converted into AC electricity, which is usable for your home. According to the MIT School of Engineering, the difference between DC, or direct current, and AC, alternating current, is the direction the electrons flow. DC is constant and moves in one direction. AC is changing and alternating, given its name. An easy way to understand this, told by Carl K. Bergeron, a professor of electrical engineering at MIT, is to imagine a graph. The DC is a flat line. It's never changing and constant. The AC is more like a wave-like pattern. So the flow of AC can be both positive and negative. Also, according to Bergeron, AC became popular in the late 1800s because of its ability to efficiently distribute power at low voltages. That is why AC is preferable in the home. So, how do we maximize the power of the sun? A promising new way, according to an article published by the Yale School of Forestry and Environmental Studies, are multi-junction cells. Multi-junction cells have separate layers of light harvesters that each gather energy from a, quote, separate slice of the solar spectrum, end quote, by using very efficient, somewhat conducting materials such as perovskite and gallium arsenide to capture the sun's energy. Perovskite is a very promising material that is used within multi-junction cells. This is a relatively new material that is highly efficient and cheap to produce as it is made from lead and ammonia. One major drawback is perovskite crystals break down in human conditions, causing it to stop working. So continual research is needed to improve perovskite cells. The demand for energy is only going to rise. We will look to fossil fuels to be our primary energy source, but soon that well will run dry. We need to look toward renewable energy sources for our answer. Solar energy could be the most viable option. With more research, solar power could help solve our energy problem. So the next time you're out in the world, take a look around. Notice everything that uses energy. And think about where that energy comes from. Odds are it's a fossil fuel. And soon that fossil fuel is going to run out. And what is always shining in some part of the world? The sun. Thank you. Are there any questions?
So generally speaking, there's a hierarchy that works together and separately to solve issues like this. So like it's the individual, business, bureaucracy, federal government. Whose responsibility do you think it is to expedite research on technology that will help us harvest more solar energy?
Are you addressing should it be a government's responsibility or a private company?
Yeah.
I think government plays a big role in it. They could help make it happen, but I think ultimately it's going to come down to a private company who has a lot of money and resources to be able to put research into it for good quality research. Any more questions?
You were talking about the different types of alternative energy. You were like biomass, something. What is that?
Biomass? Let me look back at my... biomass biofuels.
Mhm.
So I think that's just like byproducts
Okay.
of different fossil fuels.